Okay guys, so this is your first video lecture with me because I'm gone for an all-day tennis tournament. Um, I think through this week, so Monday, Tuesday, you learned how to take derivatives, what a derivative is, and you had to do like half a sheet of paper per problem because you had to do it the long way, kind of talking about the secant slope, but applying the limit to it. And it was a lot of work and a lot of algebra. And then yesterday, I taught you shortcuts, and you love shortcuts with derivatives because you can do it like that. So it's great to do the shortcuts, but you got to know how to do the shortcuts, okay? And so for this first video, I'm going to go over some of the homework problems that you guys had that I'm assuming you might have had. We're going to go over them starting with number 45. The whole thing is I want to take the derivative, okay? And I'm going to do this in red right here because this is wrong. Too often students go, okay, this derivative is 3x squared minus 6x all over 2x. Now stare at that for a moment and think through, what did I do? The top guy, x cubed, went to 3x squared. By itself, that's the correct derivative, just if it was him. Minus 3x squared goes to minus 6x. And x squared goes to 2x, okay? So you did each guy, oh, and by the way, 4, what's the derivative of the number 4? That's basically saying 0, okay? So some of you might have said the derivative of this crazy quotient is just take the derivative of all the little pieces. You can't do that, okay? You can't take derivatives of pieces of a quotient. Okay? You can't do it. Okay? So here's my little trick or metaphor to remind you of things. The power rule, the guy I taught you, the shortcut I taught you, only works if you have the cute wooden toy train with animals on it. What? Here comes another Bach metaphor for you, okay? So the power rule, again, only works if you have the cute wooden toy train. And as I'm a daddy, I definitely know these toys, and I had them when I was a kid as well. Remember when you had a little boy, little girl pulling that little train, and there might have been, yes, that's a bunny on one of them, and then an alligator on the other one, and then let's go with a giraffe. I'll put some dots on it to make it look more giraffe-like. Okay, and it was that little wooden train with the string connecting them, and you could just pull it, and you have the bunny by itself, the crocodile or alligator by itself, and the giraffe by itself. That's your goal. And if you're kind of going, what are you saying? I'm trying to tell you I need to individualize this fraction. Right now it's a fraction, but I kind of want to get it into 3 pieces. Maybe that piece, and that piece, and that piece. Okay, I'm going to show it right below here, but I need to separate it out. Right now it's like I haven't built the toy train up. Instead, it's kind of all jumbled together in the box. I need to spread it out. Okay, so for this toy train to spread out, let's take a look at the guy again. I separated it into 3 separate pieces, the bunny, the alligator, and the giraffe. And notice all I did was divide each guy on top by the x squared. So there's the yellow guy, the green guy, and the blue guy, and that's all I did. Okay? So with that, now we're getting closer to building that toy train up. Okay? What I would do first still, though, is this is still a quotient. So don't try and take a derivative yet. You don't know how to take a derivative of a quotient. But you can simplify. So this goes, what do you do with exponents? When you're dividing, you subtract. So x minus 3 plus, now, how do I move that x guy up? Like, think of this as 4x to the 0, because x to the 0 is 1. So this would turn into 4x to the negative 2. Okay, 0 minus 2 is negative 2. So this whole step from here to here is simplify the quotients into a 3-piece toy train. Now, there's no more quotients anymore. You have 3 guys by themselves. You can now use the power rule. So finally, you can use the power rule shortcut here. Power rule shortcut. So I can now go, let's see. If this is x to the 1, this would be 1x to the 0. This is x to the 0, so that would be minus 3 times 0, x to the negative 1. And then this would be plus 4 times negative 2, x to the negative 3. I'm going slow with this because it's still somewhat new to you guys. But hopefully you guys are getting a little bit quicker at just saying that's 1, that is nothing, and that's minus 8x to the negative 3. The derivative of x is 1. The derivative of any number is just 0. And then that 4 and negative 2 fall down to get a negative 8. From here, I don't like negatives and exponents. Don't like negatives and exponents of solutions. So now pull it back down, and you could say this is f prime of x is 1 minus 8 over x cubed. Okay? You need to have the negative exponent when you want to take a derivative, but once you're done taking the derivative, put it back down. Okay? Now, there were 4 more problems that I felt involved this whole idea of creating toy trains. Okay? 25 and 29, again, you had a quotient. You can't handle quotients. Okay? So these are quotients, and you don't know how to take derivatives of quotients yet. And likewise, these are products. It's something times something. You can easily see it with the 47, is it's x times x squared plus 1. And that 4x plus 1 squared, you could think of it as 4x plus 1 times 4x plus 1. So on both styles, quotients and products, you do not know how to take the derivatives yet. There is some sort of rule called a product rule and a quotient rule, and that we will work on next week. But until you know those rules, you need to change them into toy trains so you can do the power rule. Because again, the only guy you know how to do is the power rule, which is a nice shortcut, but it's a shortcut if you have toy trains. Okay? So, 25, what I would do is this. I would first pull up the x squared, not the 2. You keep that where it is. So this would turn into 5 over 2, the fraction, x to the negative 2. All I did was move up the exponent guy. Now you can take the derivative. I'll take the derivative in blue, like I normally do. That negative 2 falls down, and I get negative 2 times 5 halves times x to the negative 3, because that negative 2 fell down, making that exponent negative 3. And simplifying and moving the exponent back down, I get negative 5, because the 2's cancel, over x cubed. Okay? Now, on this next one, square root of x over x, again, it's a quotient. But if you think of this as x to the 1/2 over x to the 1, what do you do with exponents again when you divide? We did it earlier, and that's subtracting. So 1/2 minus 1 equals negative 1/2. Now that's a toy train. I'm going to highlight these toy trains so you remember what I mean by it. That is a baby toy train. I have single toy train. So now we can take the derivative. negative 1/2 falls, x, and then I have to do negative 1/2 minus 1, which turns into negative 3/2. Once your derivative is done, you can pull stuff down to the bottom. Now, be smart on this. Which part of the fraction 1/2 falls to the bottom? And how do I move the x guy down? What I would do is keep the negative 1 on top, a 2 goes to the bottom, x to the 3/2. Okay. Now, let's do 47 first because it's the smaller version of 35. Right now it's a product. You do not know how to do a power rule of a product. You only know how to do it with toy trains. But you could distribute the x and say this is x cubed plus x. Now you have a double toy train. 1 piece, 2 piece. They're separated by the plus sign. That plus sign is kind of like your string connecting the two animals on the toy train. And you're allowed to take the derivative now. And remember notation. If I start with f, I go to f prime. If I start with y, I go to y prime equals 3x squared plus 1. Okay? So 35, if you wanted to expand it out, because you don't know a product rule, but if you make toy trains, you can handle it. You can think of this as 4x plus 1 times 4x plus 1. Expand that out, gets you 16x squared plus 8x plus 1. Now, I have a toy train of 3 pieces. There's my bunny, there's my alligator, and there's my giraffe. Because you have 3 separate pieces connected by the string of the plus sign, you can take his derivative and say y prime equals 32x plus 8. And the derivative of 1 is 0, so I don't need it. Okay? So think back to Monday and Tuesday when you were doing a lot of work with the limit as h goes to 0 of that slope equation, and it took you about half a page. Here, you could do all of these super quick with the power rule. Okay? And to summarize, you don't know how to do quotients, you don't know how to do products, you only know how to do power rules. So let me write that again. So currently, you don't know how to take the derivative of products or quotients. You only know how to use the shortcut called the power rule. And the only way to do the power rule, the only way to use the power, the only way to use the power rule is if you can manipulate the function into what I call a toy train. Now, realize this is a Bach metaphor. You will not find this in a book. They will just talk about doing some algebra to get something where it's ready. Okay, so that's a little bit boring, but now you can think of toy trains with cute bunnies, alligators, and giraffes, and whatever animals you want. Okay. Now I'm going to hand out this, or the sub's going to hand out one of these worksheets that we're going to work on throughout today. Okay, and I want you to start the bottom half, which is right here. Okay. And I just want you to take the derivatives. I want you to try and take them as quick as you can. And realize some of them, like 6, are very straightforward because it's ready. Now notice this notation, d of dx, that just means take derivatives. all of these just means take derivatives, except for number 10, and this notation says take the derivative once and then take it again. So that's called a second derivative. Okay? 6 is already good. It's in a toy train. So is 8. So is, that's it about. Okay? But on the other ones, make them toy trains first. Okay? Meaning something like on 7, you should think of this as 6x to the negative 1, and I want you to take that derivative. Okay? Because now it's in the toy train. There's no more quotient. And you can say this derivative is negative 6x to the negative 2, which I would then have you say is negative 6 over x squared. Box it in. Okay? So take as much time as you need. I'm going to pause it right now. Okay? When you're ready, you can check the next screen. So what I mean by this is I want you to pause it right now. And when you guys are all done and you want to go over it, then hit play, and I'll pop to the next screen, which will have all of these answers for you to check. Okay, and then we'll go on from there. So you pause. Okay, so here it is. Here are all the answers that I did. I changed things up. All of the black is where I changed it into creating a toy train. Okay, and once you have that toy train, you can take the derivatives. But notice, I don't like the derivative answer to have a negative exponent, so then you pull it back down. Okay, those are the guys up top, and let me scroll here. Look at number 10. I will always color coordinate my derivatives. So the black is my function, and I changed it into a toy train. The blue is when I took the first derivative, but I want to take a second derivative for some reason, and you have no idea what a second derivative is yet, so just take it, and I'll teach you that later. But I took the second derivative right off of that blue, so I went from black to blue to green, and then I pulled down that exponent because I'm finally done. I completed it. Okay? So that's some practice on toy trains. The next video I'm going to look at is horizontal tangents, especially question 57 from your homework. So that will be the next video, and then the last video will be really some of the new lecture stuff. Okay, so open up the next video now because this one's done, and you can watch the next part of the lecture.